Good evening, everyone. It's great to be here. Now, there are two things that keep me up in the morning. The first is my one-year-old son, and the second is the impending deadline of my PhD research. This evening, I'm going to talk about the latter. However, first of all, I've learned that babies and rivers are actually quite similar. They both tend to destroy houses. They're quite unpredictable, and they exist in a state of wetness the majority of the time. We also spend lots of time and money trying to control them. For rivers, this exists in sort of channelization, the encroachment of the floodplain. It also occurs in the actual relocation of a river channel, where a river is moved artificially. So this is not a new phenomena. River relocations have been happening for a long time. They happen for airport expansion, for river restoration, and they also occur for alluvial mining, both historically and in present day. The first person to do a river relocation that I could find was Buff Hercules. For history buffs, as one of his 5th labors, he actually relocated 2 rivers to clean a stable. Now, I doubt whether that was actually a relocation or a flood. So a true river relocation doesn't use water in a consumptive sense. Now, my research occurs in Australia, where typically the guidelines of these river relocation channels are based on rivers in the Northern Hemisphere, and they don't always work very well. See, Australia is quite famous for having lots of dry rivers, some 3.5 million kilometers of river channels, of which about 84% are dry and intermittent. So we've got these big rivers, but we also have these smaller ones, and these are ephemeral, so that means they don't flow all year round. Now, we don't know a lot about the geomorphology of these channels, and so what happens is that we have really poor guidelines on how to recreate them, but they are very much still at risk. My research takes place in the Pilbara, and as you can see, it's famous for changing the color palette to red, to angry purple, and just desperate beige. So you may know the Pilbara from its work as a Mars analog, or you might also know it for its really cool, old, impressive banded iron formation. But what it also has is a lot of geologically younger Miocene channel iron deposits. And because of the presence of these deposits, there's lots of iron ore mines in the Pilbara. So here's an example of one. We're not watching Mad Max. So what they do is they mine underneath the Paleo channel. And so this is a concern because the rivers are in the way. So evidently, we need to move them. So this isn't on a small scale. You can see it's actually quite large. And what they do is that they create these river relocations around the site of the mine and then join them back to the channel once it's left the mining area. So to put this into perspective, now this hole you see is 2.9 kilometers squared, or about 15.6 Moscone convention centers. Or, if you're a parent, it's about the amount of food my child refuses to eat at dinner time. So what do they look like? Essentially, they're a giant flume experiment. We can see that they lack vegetation. However, they do convey floods quite effectively, but they don't look like a natural river. You've got increased sedimentation, erosion, mass failure, and generally not a very nice environmental outcome. But they are rivers, they do flow, and they're designed to convey these really large 100 to 1,000 year cyclonic events. But we just don't know how to turn them into something that looks more like a natural river. And that's where my research comes in. So I use LiDAR data to look at where the river channels are working well and where they are, well, just disappearing before our very eyes. And so those boulders are about the size of a car, by the way. And as for the small in-channel features that you'll miss by 1 meter LiDAR, I use UAVs, and I use those to survey the in-channel features. And that way we get a good idea of what geomorphology is in the actual channel and how we can best replicate that in the system. And what we found is that the channels in the Pilbara are actually quite wonderful, in my opinion. They have lots of mechanisms to transport sediment and water throughout the channel, and lots of opportunities for vegetation to colonize. So what I plan to do is start from the very basics and turn this criteria into a set of hydraulic guidelines, a thing that engineers can understand, and link that into a better understanding of our geomorphology. So in the future, Our river relocations match the reality. Okay. Thank you very much.